Today we're going to take a look at using the Geekduino sensor shield to control a digital output using a digital input. This video will work for just about any Arduino board, but we are going to focus on the Geekduino and sensor shield. If you haven't gone through the Geekduino Getting Started guide or the digital output tutorial, we highly recommend you do that. We're going to reuse a lot of that information. So we've got our Geekduino and sensor shield already fit onto it. We've got our USB cable plugged in. Like before, we have our LED driver. We've installed our LED, made sure that it matches up with the silk screen on the board. And now we've got a new board, the RobotGeek push button. So you can push it, you can hear it push, see a little resistor on there, and it's got everything you need to connect directly to the sensor shield. So let's open up the code. We're going to go to Arduino, File, Sketchbook, RobotGeek Sketches, RG101, 02 digital input, A button direct. This is going to be directly controlling the LED from the button. So as you can see, we have button pin 2 and LED pin 4. Now we used variables in our previous digital output tutorial, but they looked more like this without this const. So they were just normal variables. This const is the modifier to signify constant. So these variables are going to be constant variables. What this is going to allow us to do is save a little bit of memory in the Geekduino. Now for this sketch, it's not going to matter too much, but as your sketches get bigger and bigger, it's good practice to take any of these variables that are going to be static throughout the entire code and label them as constant. Keep in mind, if they're variables that are going to change, you do not want to use this constant modifier and you will get errors. So let's go ahead and plug in our button pin to 2 and our LED pin to 4. We'll take some of our 3-pin cables. We've got white, red, black, so the white will always go to the left for signal, black to the right for ground. So first let's put in the LED. We'll find DIO4, and we'll find the 3 pins under DIO4. Plug that in so the white's to the left matches up with the S up here at the top. On the other end, we'll get our white to the left, match that up to the S on the board. And then we'll plug in our other cable into DIO2, that's right above 4. The other side into the push button. Again, checking that all of our whites are to the left and match up to the S on all the silk screens for the boards. So now when I press this button, my LED is going to turn on, and it stays on as long as I let the button on, and as soon as I let it off, the LED turns off. So let's take a closer look at the code. After our pin definition variables, we have another variable, bool. So bool is another type of variable. It stands for boolean, so this is instead of integer. And boolean can only store 2 values, 0 or 1. So that's going to represent 0 for off or low, and 1 for on or high. And that maps to the button state. So that's going to be whether or not I've pressed the button. We're going to use bool to save a little bit of memory in the Arduino. You could put an int here, but it's a much bigger variable than you need for this data. In our setup function, you'll notice 29 is familiar, LED pin output. So this pin mode function sets LED as an output for the LED. 28 is a little bit different from before because button pin is now set as an input instead of an output. What's really nice is that all these pins are configurable in whichever way you wanted. So you could swap around your LED and your button pin as long as you change your pin definitions here and physically move your pins. It's all in the code that you're defining each pin as an input or an output. In our loop, we've got that button state variable, and we're going to take whatever's from this digital read function into button state. So digital read is going to read button pin, that's pin 2, and it's going to return either a high or a low. That's a high if the button is pressed, or a low if the button is not pressed, and store that in button state. Next, we're going to use our familiar digital write function and write to pin 13, but instead of directly writing high or low, we're going to write button state. So if our digital read read high, it's going to put a high in here, making the LED pin high and turning the LED on. If the button pin is low, it'll take the button state low, digital write to that low, and keep it off. So now let's take a look at File, Sketchbook, RobotGeek Sketches, RG101, Digital Input, Button Serial. One of the first things you're going to notice in the code is that we just have constant int button pin equals 2. We're not actually going to use the LED. Instead, we're going to use the serial monitor. So the Arduino has a hardware serial port that allows it to send and receive data to and from your computer. It actually uses this to program the Arduino as well as communicate back to your computer after the fact. So just like before, we've got our variable for our button pin, we've got our button state, we've got our pin mode set to an input. Here's where things start to change a little. Serial.begin is a function that starts the serial port. The 9600 number is the speed at which the serial port should communicate. It's 9600 is the default speed, and that's in bits per second. You can adjust this speed, and there are a lot of different standards, but we'll leave it at 9600. Now we've got serial print line. Print line is what's going to actually send data from the Geekduino out to the computer. So we want to send the text serial test, print data when the button is pressed. Since this is in the setup, it's just going to print once. Now we're going to look at our loop. Just like before, we've got our button state and our digital read, reading in from our button pin into the button state. But now, instead of setting this to an LED, we're going to send button state to this if statement. If is a logical construct in programming that will check for a condition, and if that condition is met, run some extra code. So first, if will check if button state is equal high. It's very important that you have the two equals here because this is a comparison. Whereas up here, this single equal is just assignment. So a single equal will take whatever's on the right and put it in the variable on the left. But equal will check if the left and the right match. So if our button is not pressed, button state will be low. Low equal high will return a false. And if will know that these two are not equal. It will then not run any of the extra code. However, if button state is high and these two are equal to each other, then this code in the brackets will get run. So whenever I press the button and button state goes high, I should see button is being pressed on the serial monitor. So let's go ahead and upload. Then we're going to go over here, serial monitor. Down here, the default should be no line ending in 9600. You can just click and change these if yours don't match up. As you can see, right when we started, we got serial test, print data when the button is pressed. Serial test, print data when the button is pressed. When you open the serial monitor, you actually automatically reset the Arduino. So whatever's in your setup will go ahead and show up right away. Now right now we're not getting any other data. That's because the button state is low. So this if statement is not firing. But as soon as I press the button, I should see data coming through. And I'll only see the data coming through when I press the button. The serial monitor is really useful when you're trying to debug your code. It can print out variable data, it can print out breakpoints so you know when different parts of your code are firing, and it can help you if your code's locking up or you're having some sort of other issue. One thing to keep in mind is that digital pin 0 and 1 are tied to your serial hardware. So while this makes it nice for being able to communicate with other non-computer devices like serial servos and serial displays, you need to make sure that you're staying away from those pins if you want to use the serial monitor on your computer. And like I said before, you're actually using this port to program the device as well. So if you have buttons or LEDs, don't plug them into 0 or 1 while you're programming, or you might see errors. So So that's it for the digital input video. There are some more advanced topics in digital input that you might have seen in our demo code, like button toggle and button with pull up. We will go over that in a more advanced video, but for now we recommend you take a look at the analog input video, lesson 3 in Robot Geek 101.